You already know something is wrong before you can name it. The steering wheel is in your hands, both feet on the pedals, every mirror adjusted, every condition exactly as it should be. The car is moving, you are doing everything right, and then it starts. Not in your mind, not in a thought, in your chest, a pressure, the kind that arrives before language, before reason, before any part of you has decided to be afraid. Your hands tighten around the wheel without your permission. Your breathing changes. Your vision does something strange at the edges, something you cannot fully describe, except to say that the road ahead suddenly feels like it is getting farther away and closer at the same time. Your body is telling you, screaming at you, in a language older than any word you know, to stop, to get out, to run. But you are driving at 70 miles per hour. There is nowhere to run. And the thing you are running from is already inside the car with you. This is what 40 million people experience every time they try to drive. Not nervousness, not caution. A full biological emergency response. The same system your ancestors used to survive lions on an open plain. Activated completely by the act of sitting in a vehicle they have successfully operated dozens or hundreds of times before. Their body does not know they have driven this road before. Their body does not care. And what neuroscience discovered about why this happens is one of the most disturbing things ever documented about the human brain. Because the answer is not what anyone expected. It is not about trauma. It is not about accidents. And it is not, in any clinical sense, irrational. It is not a fear of driving. It never was. The year is 2009. A man named Marcus, 31 years old, sales manager, drives 40 minutes each way to work every day, is on his usual route when he sees, in his rearview mirror, a car drifting across the lane behind him. The car does not hit him. It corrects. Nobody is hurt. The whole event takes approximately 4 seconds. Marcus does not slam his brakes. He does not pull over. He watches it happen, confirms everyone is safe, and continues driving to work. He tells his colleague about it at lunch as a mildly interesting story. He drives home that evening without incident. 6 weeks later, Marcus cannot get into a car. He does not know why. He cannot connect what is happening to him now to the thing he saw in his rearview mirror 6 weeks ago. The two feel unrelated. The event was minor. He wasn't even involved. Why would that do this to him? His doctor initially agrees. Anxiety, probably. Stress at work. The driving thing is a symptom of something else, surely. Marcus agrees. He waits for the something else to resolve. He takes the bus. He calls his wife for rides. He tells people he prefers not to drive for a while. He believes this is temporary. He does not know that inside his brain, in a structure he will never see and could not control even if he could, something has already been permanently written. Here is what happened during those 4 seconds in the rearview mirror. The amygdala, the brain's threat detection and fear memory archive, 2 almond-sized clusters buried deep in the temporal lobe, does not watch events unfold the way your conscious mind does. It does not narrate. It does not analyze. It runs a continuous high-speed pattern scan of your sensory environment and cross-references everything against a stored library of threats. When it detects a match, or even a near match, it does not wait for your cortex to deliberate. It fires. It floods the body with adrenaline and cortisol within milliseconds. And then, if the threat register seems significant enough, it does something else. Something Marcus had no idea was happening. It encodes the moment, not as a story, not as a memory you can retrieve by thinking about it, as a sensory imprint. The exact smell of the car interior, the exact quality of the light through the windshield, the precise sensation of your hands on a steering wheel, the visual field of a road through glass, branded into long-term fear memory, with a neurochemical stamp that marks it as, this configuration of sensory experience was associated with threat. Do not enter this configuration again without raising the alarm. Marcus did not have a traumatic experience. His amygdala had one, on his behalf, without asking. And here is the fact that should make you set your phone down and think before you keep watching. The amygdala encodes vicarious threat. It encodes threat that happens to someone else, near you, in your sensory field, at sufficient emotional resolution. Research from NYU's Emotional Brain Institute demonstrated that observers of near-miss events in high-stakes environments showed equivalent fear. Memory consolidation to participants who directly experienced the event, In some cases, stronger consolidation, because the observer's nervous system remained activated for longer, with no physical action to discharge the adrenaline. You watch someone almost get hurt. Your body produces the same neurochemical signature as if you almost got hurt. And your amygdala files the memory under the same category: survival threat. Real, confirmed, do not forget. You have had moments like this, behind the wheel or not. You have seen something near miss that made your stomach drop, and you moved on, and you told yourself it was nothing. You do not know what your amygdala decided to do with it. But let's stay with Marcus. The thing that makes his case extraordinary, and why it ended up in a 2014 study on vicarious fear acquisition in vehophobia patients, is what happened when clinicians finally traced the origin. Marcus, like 73% of patients in that study, could not consciously connect his phobia to any precipitating event. When asked to describe his worst driving experience, he talked about a minor skid on ice in his 20s, almost a decade before the phobia began. The car in the rearview mirror didn't even register as a candidate. It was not dramatic enough. It was not about him. It could not possibly be the reason he now cannot ride in the passenger seat of his wife's car without a white-knuckle grip on the door handle. But it was. Not because of the event itself. Because of what the event told his amygdala about the entire category of experience labeled being inside a moving vehicle. One sensory context, one threat signal, 40 million potential future triggers, every single one of them present every time he sits in a car. The sound of an engine turning over, the vibration through the seat, the peripheral movement of other vehicles, the visual narrowing of a road through a windshield. All of it is now inside the threat library. All of it now says, "Last time you were here, something almost killed someone. We are not doing this again." Here is the part where the science becomes genuinely cruel. The standard treatment, exposure therapy, gradual reintroduction to the feared stimulus in controlled, safe conditions, works. The clinical evidence is robust. After successful treatment, patients drive again. Studies report 60 to 70% of patients achieving functional recovery. These are good numbers. These are real numbers. Marcus completed a 12-week program. He drove to his own discharge appointment. His clinician marked him recovered. 2 years later, a car ran a red light 3 intersections ahead of him. Nobody was hurt. He watched it happen in approximately 3 seconds. He hasn't driven since. This is what the studies are more careful about discussing. Exposure therapy does not erase fear memory. The amygdala does not delete. What exposure creates is a competing memory, a new neural pathway that says this stimulus, previously logged as threatening, has now also been associated with safety. Both memories coexist, both are real, and the amygdala, when choosing which one to reference in a given moment, is not democratic. It weighs them by emotional intensity, by sensory match, by stress levels in the body at that exact second, by whether the cortisol already running through your bloodstream from an argument you had this morning is making the threat detection system more or less sensitive than usual. The original fear memory is stronger. It was written first. It was written under genuine physiological alarm, and it does not age. Fear memories do not degrade the way ordinary memories do. The hippocampus, which normally manages memory consolidation and decay, processes emotionally neutral memories through gradual reconsolidation. The memory changes slightly each time you access it, becoming less vivid, less detailed, eventually fading. But memories tagged by the amygdala as high threat do not follow this process. They are stored with a kind of biological priority that resists decay. The neuroscientist Joseph Ledoux, who spent 30 years mapping the architecture of fear memory, described it this way: the brain treats fear memories as survival data. You don't let survival data expire. Marcus's first fear memory, 4 seconds in a rearview mirror, 6 weeks before his life changed, is, neurologically speaking, as fresh today as the afternoon it was encoded, and it is waiting for the right sensory conditions to make itself known again. Now, here's the question that nobody has been able to fully answer, and it is the question that should keep you thinking long after this video ends. Why Marcus? The car behind him corrected. Nothing happened. Thousands of people see near misses every day and never develop any anxiety about driving at all. What made his amygdala file that 4-second event as a survival-level threat when the person in the car directly in front of him, who saw exactly the same thing, drove home without a second thought? The research points to something called threat sensitivity baseline, the resting sensitivity level of the amygdala's pattern recognition system, which varies significantly between individuals based on genetics, early childhood stress exposure, cumulative anxiety history, and even sleep quality in the days surrounding the triggering event. Marcus, it turned out, had been sleeping badly for 3 weeks before that morning. His father had been diagnosed with something serious. Work was at a pressure point. His nervous system was already running elevated cortisol when he looked in that rearview mirror. The amygdala, operating in a high sensitivity state, evaluated a 4-second near miss in a car behind him and concluded maximum threat encoding required. Another version of Marcus, better rested, less stressed, on a different morning, sees the same car drift and correct and thinks, wow, that was close, and drives to work and forgets about it by lunch. The fear was not in the event. The fear was in the state Marcus's nervous system was in when the event occurred. The road didn't do this to him. The week did, the months did. The accumulation of ordinary human stress running quietly beneath the surface of a Tuesday morning commute did. Think about the last week of your life. Think about the sleep you've had, or haven't had. Think about what was running in the background, the worry you pushed down, the tension you carried in your shoulders, the messages you didn't want to open. Now think about what your amygdala's sensitivity level might be right now, today, as you watch this. Think about what you might be about to drive past, or sit next to, or witness from a window. Think about what your nervous system, running quietly beneath every thought you're having, might be deciding to log. Because here is the final truth that clinical psychology has arrived at about vehophobia, and about the broader architecture of human fear that it reveals. The 40 million people who cannot drive are not a separate category of person. They are not more fragile, more anxious, more broken than the people who drive without difficulty. They are people in whom a specific combination of timing, biology, and accumulated stress cause the amygdala to cross a threshold that every human brain has, a threshold that has no warning light. You don't know where your threshold is, nobody does. You find out only when you cross it, and you don't get to choose when that happens, or what triggers it, or what ordinary thing, a steering wheel, a windshield, the vibration of a seat beneath you, gets filed forever in the part of your brain that cannot be argued with, cannot be reasoned with, and does not respond to the fact that you have driven that road 100 times before, and nothing has ever happened. Marcus got back into a car for the first time 2 years after his second encoding event. He sat in the driver's seat with the engine off for 22 minutes. He did not start it that day. He came back the next week. He sat for 11 minutes. He started the engine. He didn't drive. He told his therapist that the sound of the engine alone was enough. That in the silence after turning the key, with the car running and no other cars anywhere nearby and the driveway completely still, his body was already somewhere else entirely, already in a moment that had lasted 4 seconds, 11 years ago, in a rearview mirror on a perfectly ordinary Tuesday. The amygdala does not know that was 11 years ago. For the amygdala, it was this morning. It is always this morning.